Okay, show that the line joining 3, 7 and 5, 15 is parallel to the line joining -6, -8 and 2, 24. So because we want to show that they parallel, okay, remember parallel means going in the same direction, yeah? So it's going to be maybe look like that, okay? Now, in order to show that something's parallel, they've got to have the same steepness, haven't they? They've got to have the same gradient, in other words. Okay, so if we can work out the gradient, okay, for both pairs, then hopefully they'll be equal. And if they're equal, we can say that they parallel. Okay, so let's take the first pair here, 3, 7 and 5, 15. Okay, so if this is my x1, my y1, this is my x2 and y2, well, the gradient then here, remember the gradient formula is y2 take away y1. So difference in y's, because it's the rise, divide by x2 minus x1, which is the difference in x's, which is the step. So in this case, y2 is 15, take away y1, which is 7, all over x2, which is 5, take away x1, which is 3. So if I work that out there, I get 4 as my gradient. So we're hoping now that the line joining these points, when I work out the gradient, will also be 4. So let's figure that out. So if I call this x1, y1, and then 2, 24, I'll call that my x2, y2. Okay, so again, the gradient using the formula, okay, that I've got written down here. So y2, 24, take away y1, which is -8. And then over x2, which is 2, take away x1, which is -6. Okay, so if I work at the top there, I get 32, because 2 minuses make a plus, so that's 32. 2, again, on the bottom is a plus, so I get 8. 32 divided by 8 is indeed 4. So because they have the same gradient, then they parallel. So it's a bit like this, isn't it? So you've got here your 3, 7, 5, 15, and then you've got here your -6, 8, 2, 24. Okay, they parallel in that sense because you've got the same gradient. Then we need to make a little statement. We can say, therefore, okay, same gradient implies that they are parallel. Okay, and that will do as a final statement.